We will see how well that goes.
Right.
The back of your head is going to be immortalized. All right, everyone's turned it in, right? All right. Math test due on Tuesday, and the lab. So don't forget. So as we get into chapter 3, let's do a quick review of some of the stuff we did years ago. I have a vector here, and I know it's a vector because I have a magnitude and a direction. I have a vector and I want to break it up into its horizontal and vertical components as defined by my coordinate system here. So whatever letter you want to use to represent them, A and B. Why not? So how do you find A?
Take the sine of 40 and multiply it by 20. Oh, find A. Sorry, I found B.
Yeah, all right, so B, you're just ahead of your time. 20 meters per second, the hypotenuse times the sine of the angle, because sine is associated with the opposite side. Refresher. The sine and the opposite go together. Cosine and the adjacent go together. And what is that? Did I use 40 enough? I should know sine and cosine at this point, but I don't. What's 20 sine 40 degrees? Point 6. That's the sine of 40 degrees?
12.86.
12.85?
12.86
86.
degrees. Oh, sorry, meters per second.
Yep, meters per second. And down here, you were saying, Joseph?
Yeah, it would be 20 meters per second times the cosine of 40 degrees. .32 meters per second.
All right, so there's some quick checks that you can do just to see if it makes sense. If this is a 90-degree angle, that's a 40-degree angle, what is that angle?
You would just add
50 degrees.
You were saying, Chris?
You would add 90 to 40 and subtract that from 180.
Yeah. Or since it's already a right angle, you could also just subtract this, subtract 40 degrees from 90 degrees and get that one. They are complements of each other. So that one's 50 degrees. Since 50 is bigger than 40, I would expect the opposite to 50 be bigger than the opposite to 40. So I would expect A to be bigger than B. We can draw that a little bit more extremely since all my angles always seem to always look like 45-degree angles. Since it's under 45 degrees, let's just make it a really skinny one. And I think it's a little bit clearer here if that's 40 degrees and that's 50 degrees. The one opposite 50 degrees is definitely bigger than the one opposite 40 degrees. The other thing that you should check for, if you ever get a negative value, if you do sine of 40 degrees and get something negative, then you might want to check to see if you're in radians. All right. Now, over here, I have a force, 5 newtons. Oh, actually, any questions? As I was saying, we have a force here, 5 newtons I hat minus 12 newtons J hat, where I hat's that way and J hat's perpendicular to it. The main reason I put it at a jaunty tilt there is I wanted to sort of, I don't want you to be conditioned to think that I and J are always like that. I and J are in whatever direction is appropriate for the problem. That'll become especially true in chapter 4, 5, and 6. Actually, especially true once we get after chapter 3. So what I'm asking here, this is the vector because I have magnitude and direction. I don't have the vector symbol here, so what I'm looking for is the magnitude. I could also have written this as the force with the absolute value sign around it, or as some textbooks will write it, with the double absolute value sign. But I'm looking for the magnitude. Well, if I think about that, I'm just adding vectors here. So I have, this is 5 newtons in the I hat direction, plus negative 12 newtons in the j hat direction, or 12 newtons in the negative j direction, whichever way you want to look at it. So 5 newtons is this way. And then 12 newtons is that way. It's helpful to draw them with some sort of scale. It doesn't have to be exact, it's a quick sketch, but this one should be a little more than twice that one. You have to talk louder.
Why do you say the top has to be bigger than the left? Because of how it's drawn?
Sorry, still didn't understand the question. You're asking about why this is longer than that?
Yeah.
Because the one in the J, the parallel to the J, is 12 and this one is 5.
Okay.
Yeah, magnitude directly related, magnitude of the arrow should be directly related to the size. So that's 5 newtons, that's 12 newtons. The resultant, when you're adding, this is the head to tail method. The resultant is from where you began to where you ended. There's my resultant. So how would you find it?
Square 5, square 12, add them together to the square root.
Otherwise known as,
Pythagorean Theorem.
and that should be 13. I picked 5 and 12 because it would come out nicely. What we're about to embark on with projectile motion is we're going to be doing that a whole lot. This sum. Depends on my mood when I break the question. All right, so let's see if we can apply this. So you're cruising on the road. You are driving along a straight road, straight flat road, at 40 meters per second. The speed limit is 30 meters per second. There's a policeman with a radar gun. At what angle to the road must the policeman be to think you're going the speed limit? So what we're gonna do is just first draw a picture. And there are many ways of approaching it. Some people can visualize it already, but me, I like to draw a picture. So let me draw a very fancy drawing of a road. Sure, we can put 2 lines in there. This is you driving that way at 40 meters per second. Now, usually the police are down here and it's almost pointed almost as straight down the road as possible. But this one's new. He's over here. And I'm trying to figure out that angle. That is the question. What is that angle? So I want the radar to detect 30 meters per second. In other words, the component of this 40 meters per second is 30 meters per second. And I'm going to draw that 40 longer. This is getting awfully crowded there. There's my 40. And I want him to think I'm going 30. So I want this to be 30 meters per second. In essence, we're setting up our coordinate system in, there's our coordinate system right there, I hat, J hat. All right, so we have a right triangle. I know two of the sides. I could find the third side, not really completely necessary. But how would you find the angle?
Cosine.
All right, so cosine of an angle is equal to what? What's the formula?
Opposite over hypotenuse, or hypotenuse.
Adjacent over hypotenuse.
Yep, the other one. All right, the adjacent over the hypotenuse. So that is going to be 30 meters per second over 40 meters per second. The units are there. Now they cancel out since I have the same on top and bottom, and some of you experienced this in the lab when you did circumference divided by diameter, but they cancel out. What I'm left with is 0.75. So I have the cosine of theta is equal to 0.75, and therefore theta must be the arc cosine of 0.75, or on your calculators, the cosine to the -1 there of 0.75.
41.40, oh, sorry, 41.410. Oh, degrees.
Thank you. And if you had not written down degrees, what would be the assumption? That was some nice units in there. Solid good. All right, questions on this?
This actually worked real well.
I believe so. I have not tested it out thoroughly, but I have been informed from the police that they make sure that they're going as straight down the road as possible, which supports this idea. Yeah, I've never seen a policeman with a radar gun this far off the road. But then again, if they're that far off the road, I might not see them.
It's kind of like a win-lose.
But an advantage of this from the police point of view is they're not gonna get people who just happen to be over a little bit. And then when they pull you over, you're doing 80, and they pull you over, he says you're doing 70. It's not like you're gonna, no, that's not right. You're completely wrong. All right. Do some quick addition here. So 5 meters at 30 degrees plus 7 meters at 150 degrees equals. If you need a story to go along with it, we have you will walk 5 meters. So you set out some sort of grid axis, you establish what 0 degrees is, you travel 5 meters at a 30-degree angle, then you stop, and then you turn, and you do 7 meters at a 150-degree angle. For the visual, you start here, travel 5 meters at a 30-degree angle. 30 degrees, 5 meters. And then 7 meters at a 150-degree angle. Now it is helpful to sketch this out, so you have some idea if your answer is even remotely right. I know 7 meters is going to be longer than 5 meters, so if that's 5 meters plus 2 more, so that put it about like that. So 150 degrees is sort of at that angle right there, plus a little bit. Now if you want to do it really precisely, you pull out a protractor or a ruler and do that. But all I'm doing is a sketch here because we know enough math here that we can do it without, we don't have to use the graphic method. And the 150 degrees, that is the 150 degrees right there. The angles, without other information, the angle is always horizontal is 0 degrees, horizontal to the right is 0 degrees, 90 degrees up, 180, 270 down, and then 360 or 0 again. Negative angles go in the other direction, so that's 0 degrees, negative 90 degrees, negative 180 or positive 180, negative 270 or positive 90, negative 360, 0, 360, 720, etc. So all I've done is just do the addition right there. And at this point, from a scalar point of view, or let's say kindergarten math point of view, what we've done so far is the equivalent of if the teacher asked you what's 1 plus 2, and you said 1 plus 2 equals 1 plus 2. A true statement, but we haven't actually answered the question yet. So how would I draw this so we actually have an answer? Where is the answer in this absolutely spectacular drawing?
I was thinking in my head and I drew a line with my arm.
Okay, sorry, I misinterpreted.
Anything like 2 triangles and just finding out one will lead us to the other?
We have 2 triangles. Well, I want to be able to, ultimately we're going to come up with an actual answer, but right now I just want graphically, how do I draw my answer?
Is it 2 ways?
No.
No, like one, the bottom, we do the bottom first and then.
Oh, we could have done either one first, it didn't matter. I just did the first one first. We should get in the exact same place. But that does not help us yet with the answer. What is the answer? Graphic answer.
Resultant.
Absolutely, and how do I draw my resultant? From here to here?
Yeah.
But you're saying I start here, Keelan's saying we start here.
Either.
It's one or the other.
Like this. That's my small plan. What you just.
No, and I'm gonna overemphasize it. No, absolutely not. I've seen that mistake too many times. I'm hoping, yeah, put a Mr. Yuck sticker next to it or something.
I just did the Ghostbusters.
What's that?
I did the Ghostbusters sign.
Okay, all right.
From when you started.
Because ultimately what we're asking here is where am I relative to where I started? These are actually displacements. So where am I now? So yeah, we are up here, and so it is actually from where you start. Otherwise, all you're doing is just adding another one, you'll end up back where you started. That is the resultant. It is from where you start to where you end. Now, I'm hoping if you make the mistake that, and Keelan, thank you for demonstrating what not to do. If you have it going the wrong way and you add them together, what you should see is, oh, wait a second, that's completely opposite of what I drew. And then hopefully it'll think like, oh, it's right from where we start. Now we need to find this analytically. It is possible to do it if you have enough trig. If you've taken the trig course and you know law of sines, law of cosines, yes, you can do it that way. That's not required, so we are not going to do it that way. But I don't want you to not do it that way if that's the way your mind is working on the day you need to do it. Have fun with it. What we're going to do is we're going to establish a coordinate system. Since my angles are based upon horizontal, it makes sense that one of my coordinate axes is horizontal. And I will just, for lack of creativity, call it I hat. The other one is perpendicular, which means since it's a two-dimensional problem, it's either up or down. It really doesn't matter. So again, showing incredible lack of imagination, I'm going to go up. Call that J hat. And so I'm now going to break each of these vectors up into my I and j components. So we have the first one. We have this 5 meters, and that should be an M there. 5 meters, 30 degrees, And I would like a new voice, someone who has not spoken up today, to tell me one of these two sides. How would I find it? Or if you have the answer, just tell me the answer.
You would do 5 meters times the sine of 30 degrees to find the opposite angle,
Opposite side.
opposite side.
All right, so we have 5 sine of 30 degrees, which should be 2.5. New voice, how do we find this one? Oh, you could do Pythagorean Theorem, that would work absolutely. So this would be, so if I call that a, then a squared plus 2.5 squared is equal to 5 squared. So a will end up being 2.5 times the square root of 3. Which is 4.33. What is an alternate way of doing it? Pythagorean theorem, once you know this one, Pythagorean theorem works here. What's the other way of finding the side?
5 times cosine of 30 degrees.
Yep, and that's the other way of doing it. So what we're claiming here is that this first vector we can rewrite as 4.33 meters I hat plus 2.5 meters j hat. This is just polar form and rectangular form. Down that. Polar form. Rectangular form. All right, now the next one. Got warmed up. Some people are very quiet right now, and I understand some people are just shy, and some people are just not a little unsure, but now's the time to take chances, make mistakes, get messy. That's 150 degrees, 7 meters. And I want to break it up into those components. That way and that way. So, new voice. How would we solve these components?
It's the R, the left one,
Sorry,
the
no,
R.
no, actually, we're working sort of backwards. The equivalent in scalar math is if we started with a 3 and said, what can we add together to get 3? Well, 1 plus 2. So we're sort of going in this direction now. So the resultant actually is the 7 meters. We're trying to figure out what can add together to get us that 7 meters at 150 degrees.
Do we find the acute angle?
This one right here?
Yeah.
All right, what is it?
30.
Is it too early to nitpick? Thank you. You said 30 and then you stopped.
Degrees.
Yes. Now, in terms of a test, you don't have to write down units every step of the way. Just make sure your answer has the right units. So that's 30 degrees, and so now what? There's some voices I know I have not heard today.
Cosine of 30 degrees times 7.
Is which one? All right, so 7 cosine 30 degrees. Or cosine 30 degrees times 7, whichever way you want to go. So that will be
6.06
meters. And then this one right here.
sine.
All right. Or Pythagorean theorem, whichever way you like it. So And that'll end up being 3.5. So what is this in rectangular form? What am I writing here?
6.06 meters I hat plus 3.5 meters J hat.
There's something wrong with that.
Oh wait, it's in the opposite.
Which one's?
So the 6.06 should be negative.
Yes, it's negative. And now we just add the like term. Do not just add the 606 to the 3.5. Do not. I even hesitate to say it, but I've seen that just way too many times. So if you have an inclination just to add any numbers that you happen to see, try to write yourself. Or we can find a 12-step program if you need to break the habit. All right, so we add these two together, and doing the fancy math, we get negative 1 point. That's a 3. Then 6.
7.
What, 7, 3? That's right, because we don't have to borrow the last one. All right,
I hat. Meters I hat.
thank you. Plus, I can do this fancy math in my head, 6 meters J hat. So at this point, we actually have an answer. We have the sum, because I did not specify. We're going to take it to the next form, but this equals negative 1.73 meters I hat plus 6 meters J hat. Well, let's get it in polar form to see if it actually before we get polar form, let's estimate what it would be in polar form just to see if that makes sense. So I said that was 5 meters right there, and that's looking like about 5 right there. So I'm already off of my drawing here, but if I had to estimate based on my crude drawing, that's about 5 meters, and that angle, that's like about a 25-degree angle. So based on my crude drawing, I'd say somewhere around 5 meters and somewhere around 90 plus 25, 15 degrees. It is second quadrant, it is more up than over, which does make sense here. Let's find out what it actually is. So we are going, again, we define I is to the right, and this is negative, so we go to the left, 1.73 meters, and we go up 6 meters. That is a right angle, and there's my resultant. So first off, all vectors have a magnitude and direction. How do I find the magnitude of the resultant? Let's just open it up.
Pythagorean theorem.
Everyone's favorite theorem. 6 squared plus 1.73 squared equals r squared. So r is going to be, let's go with 6.7.
5.74.
There's no way. If that's 6, there's no way that would end up being 5 point something.
Well,
It's
when you get to
6.24.
6.24? Did you do?
Yeah, I
Use it.
did 6 squared plus negative 1.73 squared, and I got 33.0071. And I took the square root of just 33.
The negative also gets squared.
I did square that. My calculator must just not have done it the right way then. Yeah.
Calculator hates you. Just
Yeah.
accept it.
That's fair.
So 6.24. All right. And the angle, we now have all 3 sides to it. So we have a choice. Which trig function should we use?
Tangent.
Is there a particular reason to use tangent?
My favorite.
All right. There actually is a legitimate reason for using tangent, other than just being Brandon's favorite. Because the 6.24 has an extra bit of rounding involved, if we use sine or cosine, that would involve that little bit of extra rounding, so, you know, if you're building a piece of equipment that could cause, if done right, will save lives, or done wrong, will cost lives, yeah, do tangent. So, if I label this as theta, because, again, limited imagination at the moment, tangent of theta is equal to the opposite over the adjacent. So theta is that's 3.47, I assume. Did you do the arctan? Arctan of 3.47?
73.92 degrees.
You like building a dramatic pause into it.
I do. Keep you in suspense.
You just need some great, mysterious music to go along with it. All right, so we have 73.92 degrees, but be careful when you're writing the answer. If this were actually a quiz or test question and you wrote 73.92 degrees, I would take off for that. Why?
Negative 73.92 degrees?
Nope.
Could you told us?
Where's 0 degrees? Which way is 0 degrees?
That way.
All right, which way is 90 degrees?
Straight up.
Is this between 0 and 90?
Yeah.
So where would this angle be if you told me the angle was 73.92 degrees? Yeah, it'd be first quadrant angle. But this thing's pointing in the second quadrant. Recognize that we found this angle right here, but if you're writing it out, that's the angle we want. So it would be 180 minus that. So in polar form, this would be 6.24 meters, comma, 106.08 degrees. Not too far off of the one based upon what we had upon the crude drawing. All right, questions to here? Now, I can guess what you're thinking. You're thinking, math is fun, but is there anything that could make the math even more fun?